Alright guys, today we're going to talk about factoring polynomials. We have factored polynomials before. For us, normally we were factoring quadratics. Remember, the quadratic is a term where there is x squared is generally what we're looking for. Just a quick review, we can do this 3 different ways. We can factor by taking the GCF. The GCF would just be factoring out the greatest common factor. So letter A, the GCF would be 3x to the 5th. And you would factor this out, and you would get 1 plus 12x. Letter B, remember you're going to factor this looking for factors of 24. The factors of 24 that are 11, either away or however you can make 11, would be 8 and 3. And they both have to be negative. And then remember for this one, if the coefficient is not 1, you have to multiply the first and the last term together. And then figure out how could you use the factors of negative 15 to get positive 14 if you added them. The only way to do this would be if you multiplied 15 times negative 1. Because if you multiplied it, you would get negative 15, but if you added it together, so that's multiplication, if you added it together, you would get positive 14. Then you rewrite this as 3x squared plus 15x minus 1x minus 5. And then you're going to take out the GCF again. So 3x becomes x plus 5. Factor out a negative 1. This becomes x plus 5. One of the factors is what's in parentheses. So one of the factors is x plus 5. The other factor is what's left over. So 3x minus 1 is your other factor. Today we're going to be talking about very special factoring, and we're going to be factoring expressions that have perfect cubes and perfect squares. So let's start with the perfect squares. If you guys have this chart that I gave you earlier in the school year, this might be helpful because it's listing all of the perfect squares, or you should probably start to, really start to memorize your perfect squares. Okay, this only works if you are finding the difference of perfect squares. Remember, 1 is a perfect square. So if you look at letter A, there's really a 1 here. Okay, you're going to factor this just like you normally would into 2 sets of parentheses. Okay, the first term is 1y squared. So what is the square root of 1y squared? Well, it's 1y, right? Y times y gives you y squared. Okay, then since it's a difference, notice that there's no term in the middle. Usually we see 3 terms. Okay. These only have 2 terms, which means that your signs have to be opposing. Okay, they just have to be opposites. What is now the square root of 16? Whoops. The square root of 16 is 4, so you just write 4 twice. Because if you were to go in here and distribute, y times y would be y squared, y times negative 4, y times positive 4, and then 4 times negative 4 is negative 16. Notice that these terms are opposing, so they become 0, and so you're just left with y squared minus 16, which is what I got up here. Okay, look at letter B. Again, there's 2 perfect squares. There's 4 and there's 25. The square root of 4 is 2. The square root of x squared is x. So the first term is 2x. The square root of 25 is 5. And these terms have to be opposing, so plus 5 minus 5. Okay. Letter C, even though it says x to the 4th is a perfect square because it's x squared, right? What squared gives you 4? 2. So here's one term, x squared, and then minus 4, and then plus 4. But we're not done because x and 4 are also perfect squares. So I now have to factor this into x times x. The square root of 4 is 2. You have opposite signs. This is not a difference of squares. So this, even though you think you can break it apart, you cannot. So this would be your final answer. Okay. Letter D is going to be very similar, but write small. I'm actually going to throw letter D up here because it's going to get pretty long. Okay. x to the 8th is really x to the 4th squared, right? 4 times 2 is 8. So I'm going to first rewrite, or factor, x to the 8th is x to the 4th times x to the 4th. The square root of 1 is 1, and it's opposing. Okay? Anytime you see a subtraction sign, you have to look for a difference of squares. This is actually a difference of squares. This can be factored into x squared minus 1 and x squared plus 1. Then remember you had this term here. But we're not done because look, another difference of squares. So this has to be factored into x plus 1 and x minus 1. This is not a difference of squares, so you just bring it down. This is also not a difference of squares. This whole thing, as long as it looks and as crazy as it looks, is your final answer. Okay? For the last one, letter E, 9 is a perfect square. It's 3 times 3. X to the 6th is really x cubed squared. So that would be x cubed. This would be x cubed. Y to the 8th is really y to the 4th squared. And they have to be opposing terms. Now, you're looking here and you see, hey, look, this is a subtraction sign. Is it a difference of squares? The answer is no, because 3 is a cube, 4 is not a cube. Okay, 4 is a square, but this is not a difference of squares. So this is your final answer. Now, difference and sum of cubes gets a little bit trickier, okay, because you can factor if you have two terms and there is a subtraction sign, just like we did above, but you can also factor if there's a plus sign, if you're adding two cubes together, because remember, you can take, technically, you can take the cube root of a negative number. You cannot take the square root of a negative number. Remember, it's imaginary, okay? So there's a little formula that's up here. Let me break this down for you. I'll do these 4 examples with you guys, and then you can do the rest by yourself, and then you're going to check them. So letter A. Remember, go back to your chart. You're now looking at all of your perfect cubes. There's really a 1 here. The cube root of 1 is 1. The cube root of x cubed is x. The cube root of negative 8 is negative 2. Okay? Now, you stop there. And you tell yourself, this is your A term, this is your B term. Since it's a difference of cubes, you have to take your A and your B and apply them into this formula. So, A squared, or x squared, goes here. A times B is just x times negative 2. And then B squared is negative 2 squared, so plus 4. Okay. This is your final answer. Okay. If you could factor this, oops, you would have to. But since the only factors of 4 are 2 and 2, notice you'd have to get positive 2 and positive 2. So this would not be able to be factored, the term that I highlighted. Okay. Letter B, you have 2 perfect cubes again. You have 27. The cube root of 27x cubed is 3x. The cube root of 1 is 1. This is a sum of cubes, so I need to apply this formula. Okay. So I look at this and I say this is A and this is B. A squared is 9x squared minus 1 times 3x is 3x plus b squared, so plus 1 squared, which is 1. Letter C, you're taking the cube root here and the cube root here, and it's this difference of cubes. So the cube root of 3x, or I'm sorry, x to the 3rd is x. The cube root of x, or y to the 6th is y squared. That's your first term, minus the cube root of 64, which is 4. Then you apply the formula. So this is a, this is b. A is the first term squared, so x squared. Y squared squared is y to the 4th plus 4 times xy squared plus b squared. So plus negative 4 squared is positive 16. Okay. Number 6, I want to change this for you. I don't want to get too crazy here. So let's just make this 8y cubed plus 27. Okay. The cube root of 8 is 2. The cube root of y cubed is y. Plus the cube root of 27 is 3. We're doing a sum of cubes, so apply the formula. This is your new a, this is your new b. A squared would be 4y squared. 3 times 2y is 6y. You're subtracting. And then 3 squared is 9. So this would be your final answer. Okay. Work on the rest of these down here, and then you're going to check your answers on the Google Classroom. These are a mixture of perfect squares, perfect cubes, okay? Please make sure that before you do anything, you try to factor out the GCF. So for example, letter A, before you do anything, don't start to do anything with cubes, because even though 27 is a cube, 3 is not. I would factor out 3, so that you're left with x squared minus 9. And then you have a difference of squares. This would be 3 times x plus 3, x minus 3. Okay, I'll put the rest of the answers up for you guys. You can check them. And then there is a worksheet when you're done taking these notes. If it takes you the whole period, that's fine. If you finish early, come and get the worksheet. If not, you guys can do the worksheet tomorrow.